Okay, I'm gonna go over like one of each problem. So the first learning target is evaluate a composition function, because what you're going to do is you are going to evaluate what happens if I have my function g that is composed of function f that is composed of -2. So the first thing you do is we're going to plug -2 into f and understand its output. Okay, so f of -2, we take 2, multiply it times -2, minus 7, and that gives us -11. Okay, and now what we want to do is we want to take -11 and we want to plug it into function g. Okay, so -11 becomes my new x value, and then I subtract 8. Whoop. So my final answer is -19. Oh my gosh. So there we go. We're just gonna make that nice and big. Okay, so the next one is a fraction that is a little bit tougher, but just kind of check online. You just really have to make sure you would check the solutions online. Just really make sure you know the idea. I would take 8, I would plug it in for x, get my output, and then that brand new number, I'm gonna then plug into g for its x, and then get my second answer, and that's my final. Okay, so I will say though that the answer is -4, but you can check the solutions that I've posted online. Okay, the next one is to find. So you want to find this time a composite function. So this one's a tougher one. I will go through one of these. These one are a little bit easier. So as long as you can kind of understand this, you should be able to for sure do these on your own. Okay, so first thing we want to do is I want to look at what this means, and this is g of f. Okay, so my function g is going to be composed of f. So I'm going to take function g, which is -1 over x. But instead of just putting an x down there, I'm actually going to put the entire function f of x in that unknown variable. So now g is composed of f. But we do have function f, so I'm going to start with -1 over, and now I'm just going to change the color real quick, this function. Okay, so function f is 3 over x plus 4. Okay, but we can't have this fraction within a fraction. So what we want to do is we want to multiply this by x plus 4. But if I multiply the denominator, I'm going to have to balance my expression up here and also multiply the numerator. Okay, and the entire reason we did this is because we want to be able to cancel this out. So by this multiplication method, we cancel this out, so the whole denominator is left just with 3. Okay, this is completely gone. And then I'm going to take this -1 and I'm going to distribute it to both terms here. So my final answer is going to be -x minus 4 over 3. And that is my composite function. Okay, so these ones are a little bit easier. Okay, you're just going to take f, this entire function f, and you're going to place it in for g. But then this one, you're going to take the entire function g, the whole thing, and you're going to replace x minus 8 right here, and then subtract 8 again. Okay, and then this is dealing with a fraction, but it's a little bit easier. So again, check those online solutions. Okay, so these word problems, it's the exact same thing from the front. Okay, you are going to be looking at composite functions. Let me be able to move this. There we go. And we have two composite functions, or we have two functions, and we're just going to compose them of each other. So the number of bacteria is going to be n, and its refrigerated food is given by this function. Okay, so 2 is less than or equal to T, which is less than or equal to 14, where T is the temperature in Celsius. So the reason we have these restrictions is because this is a real life problem. So we have bacteria that's going to be growing between this temperature, okay, and it's Celsius, so this should make sense. So here's how, if we know a specific temperature, we will then, once we plug in that temperature, we're going to understand the number of bacteria. Okay, but when the food is removed from refrigeration, the temperature of the food is going to be then given by this. T is going to be time in hours. So we have the temperature, but as the time is going to start to drop, it's going to change our temperature. Okay, so our second equation is dealing with how our temperature is changing according to time. So bacteria changing according to temperature, and then temperature changing according to time. So again, here's the restriction of the time. So we're just only looking between 0 and 3 hours, and that's going to be it. But you don't have to worry about that in your problem. So the final thing is that we want to find the number of bacteria as a function of just time. So I want n of lowercase t. Okay, I want n of lowercase t. So what we can do is I can take this function, which is temperature, and plug it in for temperature. But once I do that, I'm going to make that connection of bacteria connected to time. Okay, so I could plug in a certain temperature, and then I could get an output of bacteria, and then we could plug this in. We could use both of these equations twice, or once and then again. Sorry. But instead, what we're going to do is we're going to put these two together. We're going to compose them of each other, and then we can get our output. Okay, so I'm going to take this entire equation, and instead of having temperature, we're going to replace it with the entire function of time. So I'm only going to start this one for you guys, and then I'm going to have you check the answer. But I have 200. And then in parentheses, I'm going to substitute this function. And I'm going to square it. Minus 80, substitute that function, plus 500. Okay, so what I'm going to do now is I'm going to say this is for t plus 2 and for t plus 2. So now this entire function is a function according to time. I no longer have my capital T, I completely replaced it. But this is not your final answer. I want the entire function. So what you now need to do times everything you FOIL, and then you're going to distribute. So you're going to have minus 320T minus 160 plus 500. Okay, but now again, go ahead and you finish the rest or look at the solution. Okay, and the only part with this one is you are given an equation. Here's volume of a circular cone, and here's your equation where I have 1/3 pi, and then I have a radius and I have a height. Then they say if a height is twice the radius. So here's where you want to take this and you want to put it into an equation. Height is h, means equals twice the radius, 2r. Okay, so express volume as a function of r, which means I do not want to see an h anymore. But since h equals 2r, we're going to replace that right there, multiply everything, and get a final answer. Okay, moving on. So now I'm going to be looking if a function is 1-to-1. And in order to be 1-to-1, you have to pass the vertical and horizontal line test. So this passes. This is a function, and it's 1-to-1. Okay. This is a function, pass the vertical, does not pass the horizontal line test. All right, and then to find a function's inverse, to graph that, what you're going to do is you just switch the x and the y value. So what I would suggest is find each ordered pair. So this ordered pair would be 2 over 2 up 1, 2, 3, 4, 5, 6. So the ordered pair would be 2, 6. Now, if I want to graph the function's inverse, I have to know that the inverse point would be 6, comma 2. So I'm going to go over 1, 2, 3, 4, 5, 6, up 2. Come on. It's not going to work. Okay. And then there it is. Just pretend that that's real nice. Okay, so do that with the rest. Again, that's a pretty easy concept, so check the rest. To verify, when we verify that the functions are inverses, we need to take g and plug it into f of x, and then we have to simplify everything, and our final answer should just be left with an x. Then we're going to take f, and we're going to plug it into g. When we simplify, we should also equal x. If that is the case, then we do have inverse functions. So I'm going to start with f of g of x. So f is 5, g of x is 1/5 x. And then if we simplify this, 5 times 1/5 is going to cancel those out, so we are left with just x. Alright, and then I'm going to start with g of x, so that's 1/5, but instead of x, I'm going to go ahead and plug in f of x. 1/5 times 5 again is going to cancel out my 5's, and I am left with just x. So that's all you're doing. You're plugging the functions into one another. If your outcome is an x both times, then yes, these are inverses. Okay, so in order to understand if a function is an inverse, to find its inverse, you need to switch. Here, this is technically y. You need to now make this an x, and then you make an x the y, and then you solve for y. Okay, but I'm going to show you the harder one. I'm going to show you number 12. Okay, so I'm going to rewrite my function, and so it's going to be x instead of y, and then it's 2y minus 3 over y plus 4. Now I don't want a fraction, so right away what I'm going to do is I'm going to multiply both sides by y plus 4, because when I multiply both sides by y plus 4, that allows me to right away kind of get rid of this fraction and focus just over here. Okay, so what I'm going to do is I'm going to distribute my x. So now I have xy plus 4x equals 2y minus 3. So the goal is that we need to solve for y, and I have a term that has a y, and then I have a second term with a y, but separate side of the equal sign, right? So what I'm going to do is I'm going to move this over here, and then I'm going to take this 4x and I'm going to move it to the other side, because we want anything with a y on one side of the equation. So now I'm going to keep my xy over here, but I'm going to subtract 2y from the right side, move it over to the left side. And then I'm going to subtract the 4x so I can move it over to the other side. And this is awesome because now what we have is a GCF. Okay, so I have a y in both terms, so I'm going to take that y completely out. And so I'm left with x minus 2. And then the final thing I need to do is I need to divide both sides by this, right? So I'm going to write my final answer. So I have my negative 4x minus 3 all over x minus 2. So to find domain and range, the domain this is a rational function, so I'm going to start with our original function. The domain is going to be broken up by the vertical asymptotes, and a vertical asymptote comes just from the denominator. So if I were to set this equal to 0, there is a vertical asymptote at x equals negative 4. So that's what's breaking up my domain. So my domain is going to be negative infinity to -4. Oh, that is thunder right now. And then -4 to infinity. Okay, now what's really awesome is that my function's domain is my inverse range because everything switches. So negative infinity to -4, -4 to infinity. Okay, so there are two ways to figure out the range of your original function. You can either find the domains or the inverse domain, or you can actually find the horizontal asymptote. So if you remember, you check the degree to understand asymptotes of horizontal. And since the degree is the same, it's a 1 compared to a 1, you look at the leading coefficient. So there is a horizontal asymptote at y equals 2. So that's breaking up my range. So it would be negative infinity to +2, and then 2 to infinity. Now, if you were not very clear about that, okay, then I sure hope you can figure this out. The vertical asymptote, okay, is going to be at x equals 2, and that breaks up my domain. A vertical asymptote breaks up the domain, and that's where I would get negative infinity to 2 to, that's a 2, to infinity. Okay, so again, see how those are exactly the same because they just switch. All right, finally we are going to get to our graphing. Actually, I'm going to make a new video. Okay, so 1 second.